Hi everyone. I'm gonna continue with the chain reaction, not the chain reaction, the chain rule, okay, for composite functions, and then we're gonna pass on to implicit differentiation. Implicit differentiation is when you don't want to separate the x and y. You don't want to isolate all the y in one place and all the x in one place, but the y as a function of x and then differentiate. You want to differentiate with x and y all over the place together, even multiply together. So we're going to see that today, okay? So let's continue with the composite functions here, using the chain rule to differentiate them. G of t equals minus 7 divided by 2t minus 3 squared. Okay, so let's do this. The minus 7 is just a constant. The outer function is to the power of minus 2, because this is in the numerator. Okay, this equals minus 7 2t minus 3 to the minus 2. Okay, so what you want to do is to differentiate the outer function, which is the minus 2, and differentiate the inner function. Okay, so this minus 2 comes over here, multiplying to the minus 7 equals 14. So, and oh yeah, g is a function of t, so we're actually deriving all this stuff, we're differentiating all this stuff with respect to t. Okay, so it's just going to be 14 times 2t minus 3 to the minus 3, and then you want to multiply to the differentiation of the inside function, which is 2, so that makes this 28. And that's it. So this is 28 divided by 2t minus 3 cubed. Well, I'm just going to show a bunch of examples here. Okay, so y equals sine of 2x, differentiating, outer function sine, the inner function 2x. So it's going to be cosine of 2x times 2. Cosine, this is another one, okay, that's an example. This is another one. Now this is the third one, cosine of x minus 1, differentiating. Yeah, that actually, this is not equal, this is differentiating. Differentiating, we have minus sine of x minus 1 times the derivative of x minus 1, which is just 1. Tangent of 3x. So differentiating, we have the secant squared of 3x times 3. The inner function is 3x, the outer function is tangent. Cosine of 3x squared. Differentiating, it's going to be the minus sine of 3x squared times the derivative of 3x squared, which is 6x. Okay, let me think here. Yeah, this is something fun. It's something that catches you. Cosine of 3x squared. You gotta remember, we're differentiating, for example, this example here, just this one, with respect to x, okay? So cosine of 3, well, the cosine of 3 is not gonna change. It's not the cosine of 3x. It's the cosine of 3. That's a constant, okay? So you just gotta repeat this constant. It's gonna be the cosine of 3, okay, times the derivative of x squared, which is 2x. Okay, here we have the cosine of 3x squared. Now, it's not the cosine squared of 3x, it's the cosine of 3x squared. So first you gotta put this in another form, like the cosine of 9x squared, okay? And now all you gotta do is differentiate it. It's gonna be the minus sine of 9x squared times 18x. Let me think here. Cosine squared of x. Differentiating. So we have three functions here. The squared of something is the outer function. The cosine is the middle function, and the x is the inner function. So we're going to do this. It's going to be 2 cosine of x. I differentiated the outer function. Now I'm going to differentiate the middle function, which is the cosine of x. So times minus sine of x times the differentiation, the derivative of the inner function, which is just x, which is just 1. So times 1. And there you go. Okay, I'm not going to put all these things together. Actually, this is just minus 2 cosine of x sine of x. The next one, square root cosine of x. Well, the outer function is, here we have three functions again. The outer function is the square root, the middle function is the cosine, and the inner function is the x. So differentiating, we have half cosine to the minus half of x, okay, times the minus sine of x times 1. Let me think here. Yeah. In another form, this is going to be minus sine of x divided by 2, okay, which is, so the minus sine of x is taken care of, the 2 is here in the denominator, and then you have the square root of the cosine of x. I'm going to erase all this stuff. sine cubed of 4t. So we're going to differentiate this with respect to t. Okay. So it's going to be 3 sine squared of 4t. Okay. So we have three functions here again. The cube is the outer function, the sine is the middle function, and the 4t is the inner function. So we have 3 sine squared of 4t times the cosine of 4t, because now I'm differentiating the middle function, which is the sine, and times 4, which is the inner function, the differentiation of the inner function. Yeah, let me think. All right. Now we're going to start messing with implicit differentiation. Now here we go. You have something like this, x, y equals 1. And then you're going to think, okay, so first we make this y equals 1 divided by x, which equals x to the minus 1. So differentiating this, it's going to be minus x to the minus 2, which is minus 1 divided by x squared. Okay? Now what is this? This equals dy dx, because we isolated the y here. See? Now, implicit differentiation, in implicit differentiation, you don't have to isolate the y. Okay, so what do? You want to derive in here, you want to differentiate everything here with respect to x. Okay, but y is a function of x. So here's what you can do in here. I'm going to do the same thing, but with implicit differentiation. You are differentiating these two with respect to x. So this is the product rule. I'm going to differentiate the first one, which is just 1, okay? I'm going to repeat the second, y, plus. Now, you got to repeat the first one and differentiate the second, but you can't differentiate the second with respect to x straight, because this is not x, this is y, but y is a function of x. So what you can do is differentiate the y with respect to y, and then differentiate the y with respect to x. The implicit rule is the chain rule. Is the chain rules used for x's that you don't want to separate from the y's. Okay? So this is what we're going to do. So again, derivative of the first, which is 1, repeat the second, plus repeat the first and the derivative of the second. Well, dy with respect to y is just 1. But you have to multiply that to the dy dx, because y is a function of x. Okay? So d times, let me put a times here, times dy dx, all right, equals 0. Why? Because you differentiated this side right here with respect to x. So this one, you also got to you differentiate with respect to x, and 1 is just a constant. So let's see what we come up with here. So you have this stuff in here, okay? And then you're gonna do like, gonna keep going. You want to know dy dx, right? So here you have, you see, you got one term here, another term here, and this stuff. So this is adding, is gonna pass to the other side, subtracting. So what do you have? You have dy dx. This thing here is gonna pass over here, subtracting. So equals minus y divided by x, because x is multiplying here, so it passes to this side dividing. Okay, this is just 5th grade mathematics. So divided by x. And then you go like, okay, this is kind of crazy. Well, it's done. Okay, is dy dx this? Yes, it is. This is right. But then you're going to say, oh, this is different from this. And here you have minus 1 divided by x squared, and here you have minus y divided by x. So what the heck is up with that? But it's not different, because what is y? Y is 1 divided by x. So this equals minus 1 divided by x divided by x. Okay, this x in here is not this x in here. It's not. This x in here is this x in here. This one. So you have minus 1 divided by x divided by x. So it's divided by x squared. Now look at this. They're the same. See? It just works. Another example. X squared minus 2y cubed plus 4y equals 2. And I'm telling you, okay, the exercise has to tell you this. Y is a function of x. Is it a function of x? Yes, it is. But it's kind of complicated. You see, let's try to isolate this. So you have y, let's put minus 2y squared plus 4 equals 2 minus x squared. So you see, you have, I'm gonna have to, you see, pass this thing here, dividing over here, or you can pass this stuff, you can keep this on this side and pass this one over here dividing, but you can't really separate. Can you see what's happening here? You can't really separate, like put it in this form, like y equals bunch of x in here, ta 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 ta, and plus another x, and ta 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 plus another x. But with the y isolated, it's kind of hard. So how do you implicitly differentiate this stuff? The exercise has to tell you y is a function of x. So y is a function in terms of x. Okay? Knowing that, you can differentiate y with respect to y and then y with respect to x. See, this is what I'm going to do over here. For example, this y cubed. I'm going to do y cubed, differentiate this with respect to y, and differentiate y with respect to x. That's what I'm going to do. So here we go. This one is just 2x. This one over here is going to be minus 6y squared times dx dy. dy dx times dy dx. Okay? Plus, also this one is a function of y. So you want to do plus 4 dy dx equals 0. So you differentiate it, even though it's indirectly through the chain rule, you differentiated this whole side in here with respect to x, and this one with respect to x. Now, let's keep going. Okay, so I'm gonna isolate the dy dx in here, okay? I'm just going to move this thing a little bit down over here. So this is going to be dy dx, and then I know that you got minus 6 minus 6 y squared plus 4, okay, equals minus 2x. So dy dx equals minus 2x divided by minus 6 y squared plus 4. And that's it. So you can see that the derivative of y with respect to x depends. This is the first time in the course that this happens. It depends on the value of x, and it also depends on the value of y. Okay? Because before, y was just a function of x, and the derivative, right, the tangent to whatever graph this represents was just going to depend on the value of x. Well, now it depends on the value of x and on the value of y. Okay? Now, this is the end of the exercise. That's just it. dy dx equals this. Now I'm going to erase this again. Just to make things simpler, all right? Let's just say that you have y cubed, and you want to differentiate that stuff. So the exercise has to tell you, you don't have to guess. The exercise has to tell you that y is a function of x, and you want to differentiate this with respect to x. So what do? You do this. Okay, it's the chain rule. So this is going to be equal to 3y squared dy dx, and you're done. Let's try again here. Another example. X plus 3y. Differentiate this. Oh. Okay. Okay, so with respect to x, okay, so you're going to do 1 plus 3 dy dx. I don't know if this is clear because this is kind of complicated. So this is what I'm doing. You got a 3y here. How are you going to differentiate this with respect to x? You're going to do this. What I'm doing is this, guys, plus the derivative of 3y with respect to y multiplied by y with respect to x. So this equals 1 plus deriving 3y with respect to y is 3 times dy dx. And you're done, okay? So differentiating this with respect to x, you get this. Another example, x, y squared. Differentiate this with respect to x. So this is also the product rule, okay? So it's going to be differentiating the first one. So it's going to be 1 times y squared, y squared, okay, plus x 2y dy dx. I just differentiated y over here. I just differentiated y squared with respect to y, which is 2y times dy dx. Okay, so what the heck is this stuff? Okay, this is y squared plus 2xy dy dx. Okay, what the heck is this? This is this stuff differentiated with respect to x. This whole stuff, okay? It's not just the y squared, it's everything. You differentiate this with respect to x, you get this. Okay. you can see that the exercises are just going to get much longer. Okay, first it was easy stuff. The exercises are just getting larger. Okay. So what do you have here? You have y. Oh yeah, there's something else too. When you want to do implicit differentiation and you know that y is just a function of x, instead of writing dy dx, dy dx, dy dx, this gets old very fast. Crazy stuff. Okay, so this gets old very fast. So instead of using this notation, we just use this notation, a y with a prime. Okay? If you're going to differentiate it twice, like derivative of, if you're going to differentiate y with respect to x twice, this is the notation, d2y dx2. Okay, that's the notation here. Then you do this. If it's twice, you do this. If it's 3 times, instead of writing this, instead of writing like this, you write like this. Y with 3 primes in here. So we're going to start using this notation because it's a lot better. So what I'm doing is differentiating all of this with respect to x. And since you're differentiating the left side with respect to x, you also got to differentiate the right side with respect to x. Let's do that. This is going to be 3y squared y prime. Remember, you got to multiply it by dy dx plus 2y y prime minus 5y prime. What's going on here? What is minus 5y with respect to dy? It's just minus 5. But you got to multiply that to dy dx because it's chain rule. It's implicit differentiation. So it becomes minus 5y prime. Okay? Minus 2x squared equals 0. Alright? Now you got to collect these terms here. So let's just make the y prime. And you got to factor out, right? So you got a 3y squared here plus 2y minus 5 equals, I'm going to pass this over here with a minus sign, with an inverted sign, so equals 2x squared. And then you do, you pass this thing here, dividing. I'm just going to copy it, like, just going to move it over here, dividing. Yeah, I'm going to get this equal, put it over here. And this thing is dividing, so it's like this. And there you go. I'm going to put the equal here. I'm just rearranging this stuff. And this. Okay. And then you go like again, what the heck is this? What is this? This is this. It's the same thing. And there you go. Okay? And guys, oh, let's do a little more. Here you have x squared plus 4y squared equals 4. Differentiate everything with respect to y, to x. So 2x plus 8y y prime equals 0. Okay? And then you want the y prime, right? Because you want to know what the differentiation is. So y prime is going to be equal to minus 2x Now you're going to divide this stuff, divided by 8y. Simplifying this two, going to be equal to minus x over 4y. Okay? And you see, this right here is the equation of a slope, is the equation of an ellipse, all right? An ellipse like this. Let me draw kind of like that, something like that. Okay, and it's asking, hold on, it's an ellipse kind of like this, and this, the exercise is asking for the slope at the point square root of 2 and minus 1 divided by the square root of 2. So there's a point in the Cartesian plane, okay, Cartesian coordinates, that's square root of 2 and minus 1 divided by the square root of 2. So this is the value of x, and this is the value of y. So when you plug this in here, what do you have? What's the slope? It's a point kind of here, and the slope is going to be like this, you know, kind of like that. I'm going to show you guys. So let's just plug these values in here. So at that point, okay, I'm going to plug this in here now. So it's going to be minus the square root of 2 over 4. And you gotta multiply, right? So it's going to be, actually, it's going to be multiplying here. Minus 1 divided by the square root of 2. Okay? So this is actually a fraction. Okay, this is the numerator and this is the denominator. Let's do this here. Minus square root of 2 times. You invert the second one, okay? So it's going to be times minus square root of 2 divided by 4. Because remember, when you have fraction division, okay, you have like a divided by c divided by c divided by d. How do you do this? You do a divided by b times d divided by c. You multiply to the reciprocal of the fraction in the denominator. So that's what I did here. So here you have a plus and a plus because multiplying. Now square root of 2 times the square root of 2 times the square root of 2 is just 2. 2 divided by 4 is 1. It is, well, you see, this is going to be equal to 2 divided by 4, and simplifying is going to be 1/2. What does that mean? That the tangent's 1/2. So as x goes in here 1, y is going to go half. X goes another 1, y is going to go half. So you see here, this is kind of like the slope, and you can see that this is very much like this. Now I'm going to show you guys what I'm talking about. Because all these things that I'm showing to you guys actually comes from a book. Of course, it's not I didn't make these graphs, you know. I'm just explaining this because it comes from a book. So you see here, I'm going to get a dark color now. This is the slope in here. It's actually a blue. So this is the function that defines this ellipse. Okay. And that's it. Now let me think here. The next example is very error prone. I'm going to do just the beginning. I don't know if I'm going to do the whole thing, because there's so many calculations that if I make a mistake here while I'm making these videos, never mind, you know, it's just that too many calculations. Sometimes you forget a sign or something. So 3 times x squared plus y squared equals 100 xy. Okay, let's try to do this here. I'm just seeing something here. Yeah. Okay, so let's do this. Here you got not only implicit differentiation in the chain rule that you're going to have to use, but you also have composite functions like this square is the outside function and this is the inner function. Let's do this. Here's going to become, first I'm going to I'm differentiating both sides with respect to x, okay? So I'm doing this dx, and here also dx. So what's going to be? This 2 is going to come over here. The 3 is just a constant. So it's 3, right? This 2 is going to come over here, and this 2 minus 1 is going to become 1. So it's 6x squared plus y squared, and it just becomes a 1. Now you got to differentiate, you got to multiply to the differentiation of the inner function. And the differentiation of the inner function is going to be 2x plus 2y, y prime, remember? Y squared, you differentiate it with respect to y, and then you multiply by dy dx. So you have this here, equals 100, which is just a constant, and here you have the product rule. So differentiating the first one, it's 100 times. And here you got a 1 times y is y plus x y complement or y prime. Okay? So first I differentiated the first one, x with respect to x, which is just 1, and repeat the second. So there you go, the second is here. Now I'm going to repeat the first, which is x in here, that's why I got an x in here, times the differentiation of the second. So you differentiate y with respect to y, which is just 1, and then you multiply to the implicit part, which is dy dx, which is this part here. Okay, and that's it, guys. You know, you can collect these terms if you want. I mean, if you want to multiply all this stuff out, you can. I'm not going to do that, okay? You can multiply all these things in here, and then you multiply all these things in here, and you isolate. You bring, for example, this, whatever accompanies this term over here, okay? And then you factor out the y prime, and then you do all these things in here, but I'm not going to do that. I don't think I'm going to do that. It's just, you know, very error prone. So, yeah, let me think here. If I do this, yeah, I don't think so. I don't know. You can put a 6 here. Okay, and then you have to multiply these things. I don't think I'm going to do it. You guys can just multiply this out if you want. Because this is just 5th grade mathematics, okay? It's very error prone because you're going to have to multiply this one by this one, and this one by this one, and then the result of this, you got to multiply by this, and you got to multiply by that, and then you have to multiply this, and then you got to multiply that, okay? Got to multiply here, got to multiply here, got to pass stuff here, got to pass stuff here. So I don't want to do that. Let's try a simple one for a change. Here, differentiate everything with respect to x. Okay, so this is going to become cosine of y prime equals 1, y prime equals 1 divided by the cosine of y, which is just the secant of y. And there you go. Okay, this equals dy dx. Okay, so now you got the function of a sphere here, not of a sphere, of a circle, okay, with radius 5. The radius in here, right? This is in the form, the circle centered. The center of the circle is at the origin, and then you have like x squared plus y squared equals r squared. So this is this, that means that r equals 5. Okay, so let's, the exercise is asking for the second derivative. All right, so we're going to differentiate everything with respect to x, and then we're going to differentiate everything with respect to x again, because it's asking for the second derivative. So let's do this. 2x plus 2y y prime equals 0. All right? So we do y prime, which is the first derivative, equals minus 2x divided by 2y, which equals minus x divided by y. Okay, that's the first derivative. Now it's asking to differentiate this again with respect to x. Okay, so this is going to be the division rule. Remember that it's y minus the derivative of minus x, and then minus x times the derivative of y divided by y squared. Okay, so this is the first part of the exercise, and now I'm going to do the second part of the exercise. So let's do it. It's because, guys, remember, I don't know if you remember this, it's the derivative of f of x divided by g of x. That's what I'm doing, okay? F of x is minus x and g of x is y. So g of x is y times the derivative of minus x with respect to x, which is just minus 1. So I'm going to put a minus here. Now minus, it's this one which is minus x, so I'm going to put plus x times the derivative of this with respect to x, which is just y prime. Okay, and you divide the whole thing by y squared. So let me think here. Yep, that's it. Now we found y prime. Okay, y prime is minus x divided by y, so we have to multiply this here. So this equals minus y plus x times this. So actually it's going to be a minus, okay? Because you got plus x times minus x. So this is going to be minus x squared divided by y, okay? And the whole thing divided by y cubed. Not y squared, okay? So actually, this is gonna be the, or this equals, I just wanna, let's see here. It's asking to evaluate the derivative at the first, the tangent, okay? It's asking to evaluate the tangent, which is in the first and second derivatives at -3 and 4, at the point -3 and 4. So if you do -3 and 4 in here, okay, the point -3 and 4. So if you do -3 and 4 here, it's just going to be 3/4. Okay. Now -3 and 4 here. Well, let's see what this is going to come up to. It's going to come up to -4. This is x and this is y. -4 minus with a minus is going to be a positive. So 9/4 divided by 16. Okay, now you can do this here, and then you transform this into a 16. All right, now 16 minus 16 plus 9, it's gonna be -7. So this equals -7/4, okay, divided by 16 is gonna be -7 over 64, I guess. Nope. It seems, let me see here. Minus y. Seems that I made a mistake here, guys. Oh well. Seems that I made a mistake here someplace. Let's try to check the derivative of this again. Okay, so it's going to be it's just going to be y times the derivative of this is going to be -y. Okay, then you got a minus, and it's minus x, so you got a plus x in here times the derivative of that, which is this, divided by y squared. Okay, this is going to be -y plus x. Oh yeah, got a plus here and a minus. No, but I did that. Okay. Now, all right. The thing, you see, that's what I'm talking about. Make mistakes in here. Just that this is a minus. So this is not going to be a +9. Everything is right, guys. Everything I had done was right. Let's just do this part here. Okay, what's happening is that plug the 4 in here, so it's going to be -4. Now you got a minus here. You see, when you plug the -3 in here, you're going to get a 9, but you have this minus. So it's going to be -9/4 divided by 16. Okay, now taking the minimum common denominator here, this whole thing is going to be 4, and this is going to be -16 minus 9/16, which is going to be minus 25 over 64. Yeah, I have forgotten, you don't have to worry about this stuff. It's just when I put a 9, I was like, okay, I got a minus 9, but because it's squared, it's going to be a plus 9. But no, that's not the way it works. You get this minus 3 and you put it inside this square, x squared, you get a 9. Now, that 9 is being influenced by this minus here, so it's a minus 9. Okay? That's what happened. So, minus 16 minus 9 is minus 25 divided by 4, and dividing the whole thing by 16 is minus 25 over 64. And there you go. Now, let's see. Let's try another one. You see, these things are becoming more and more complicated and error prone. Let's try this one here. X squared plus y squared equals y squared. Now, you see, since I gotta divide this by x, and I also gotta divide this by x, I could use the product rule here, but to simplify, I'm just gonna multiply it out. So it's gonna be x to the 4th plus x squared y squared equals y squared. And I'll differentiate both sides with respect to x. So it's going to be 4x cubed plus, oh yeah, in here, I'm going to have to use the product rule anyway. I'm not going to escape from it. So differentiating the first one and copying the second plus copying the first and differentiating the second equals differentiating this, and there you go. It's ready. Okay, it's done. Of course, you know, they want you to group all this stuff together. Let's see if this time I want to do this. So here's what I'm gonna do. I'm gonna pass this stuff over here, and these I'm gonna pass over there. Okay, so it's gonna be 2y prime. Now passing this over here, I can just factor out x squared minus 2. Okay, no, it's not x squared minus 2. It's minus 1. Let's see, this stuff is coming over here. You factor out the 2y prime and got an x squared minus 1, yeah, equals minus 4x cubed minus 2xy squared. Okay, and now I can just get this thing here and pass it dividing here. I can also get this and pass it dividing here. Divisions here. And there you go. Y prime, so the dy dx, okay, this is equal dy dx equals all this stuff. It's going to be minus 4x cubed minus 2xy squared divided by 2y times x squared minus 1. Let me just see here. The book, because this is an exercise from the book, of course. The book is simplifying this because you got even numbers all over. So you can get rid of this 2. You can get rid of this 2. And this 4 here becomes a 2. You're dividing everything by 2. Okay. Let me get this And the book is always yeah, that's the same answer from the book. The book is inverting this, is putting 1 minus x squared, but it's also inverting over here. Then this becomes a positive, because you see, you can do this. You can do equals 2x cubed. Let me just I'm factoring out the x, okay, and then you can do a plus y squared here, yeah, and then divided by y. And since you inverted this, I mean, it was all negative here and now it's all positive, so you gotta invert these two here too. And let me see. Yeah, that's it. Yeah, on the next video I'm going to show you guys applications now because these are just theoretical mathematics exercises. Now on the next video I'm going to show you guys applications in real life. Why do you use that stuff? Okay, so see you guys on the next video.